Hi, welcome to another video on my Raspberry Pi with pulse width modulation and some electronics. Last time I tried to get this motor working on 5 volts and pulse width modulation without the use of this operational amplifier, and it kind of did not work. I wondered why, and a test showed that when the voltage is turned up, it will run, but when the pulse width modulation is applied, it won't run. And that is a bit odd for a motor that is supposed to be operated by pulse width modulation. Now, in another experiment I've done exactly the same. Actually, I'm doing exactly the same, and with the same voltage, actually 5 volts. However, there it turns out that although the specification of this motor shows that it operates within a range of 40 to 120 Hz, it also operates from 30 Hz. So what I'm going to do is to start the program I've used altogether, my own written GPIO motor program, and if you have watched my videos on this topic before, I can change between 0 and 1024. And what I want to do is to see which value actually comes straight from this pulse width modulation wire. Is that in the frequency range I can use? Because if it runs somewhere on 5 volts, it can run here on 5 volts. And then I just would have to change somehow the pulse width. So, first of all, I'm going to start program. Then I have to give, of course, a value. So let's go for maximum, 1024. Then I will have to select mass, and well, this whole line here is mass, so it doesn't matter where I pick it. Let me take it here. Now another thing is, of course, pulse width modulation is coming straight from this line, so I'm measuring here, but then I also have to switch on my multimeter, and I am measuring in kilohertz, 9 kilohertz. So that is way too much. And let me change the position, the angle of the camera, so you can actually see what I'm measuring. So once again, one probe on the minus, one probe here, and you can see it is about 9 kilohertz. So I'm going to change to 0. And with the value 0, it says it's 0 kilohertz. So I'm going steadily up. 10. Which is immediately 6 kilohertz. Or is it kilohertz? Is it? Yeah, it is kilohertz. So this is kilohertz and this is lower than kilohertz. Let me go down to 5. Then I would know in which direction to go. This is 3. Let me go up to 25. Just testing. And this is 15, so I should go down. Interesting results. Just on this direct on the pulse width modulation feed. So with these values I want to check some more and see if I can go to 30. Now in the past I noticed that the value of 512 was a breaking point, so let's see what that brings. None, and that means that it is larger than 20. It is somewhere in this range, which I don't need. So I'm going to 1. Let's see again. This is 600 Hertz. Now I wonder what would 1020 do. Okay, it's 2 kilohertz. 1022. Eight. Is it? Yeah, around 8. So back to 1. Which is 600. Now I haven't tried broken numbers before in this program, so let me go to half. Zero. 0.9. It doesn't object, but it doesn't say it works either, so nope. 0. 0.99. Oops. I have to interrupt the program because it doesn't work nicely anymore. Starting again. I'm going to 0.9. Yes, now it does something. 0.99. And there it breaks. That the program does not like. Okay, starting again. So taking 1 again, it doesn't come under 600 Hertz. So my first indication is, and this is of course low scale, so let me, for testing sake, test 1023. It's way too much. So what I need is to figure out how I can either electronically or programmatically go below this, the 600 Hertz, because that needs to be changed. If not with the program, then in another way. So let's figure that out. So I've been looking into the code of the pulse width modulation, which is simply wiring PI, and I've been looking at the website. Information states that you can alter anything, since it is completely open source, and the minimum frequency that you can get, or yeah, actually the minimum frequency is 100 Hertz. Now 100 Hertz is well within the range that I'm looking for, which is, as said, 40 to 120, or in case it is has been proven for the motor capable 30 to 120. But as you've seen with the measurement, I'm not getting any lower than 600, or to emphasize it, 600 instead of 100. Now also it is being used within this function, and with this function has the parameter value, and if you increase that value or decrease it, you can get it the way you want. However, it is an integer, and the way this is written, it is getting its value from another point, from another place. So let me get once again to the code. Here we are, int value. So I am looking for value which is there, and here, and here, and here. And since it is an integer, integer are real numbers, so if you look mathematically, you have the natural numbers, which are 0, 1, 2, 3, etc., etc. And an integer is a natural value, natural number up till 32,767. So 32767. However, this won't go that far, and looking here, there's no more occurrence of value, so let's go up. There's no more value, so it doesn't get it from here. The question is then, where does it get its value from? And that's a very good question. Another point is that where is soft PWM write getting its getting called? So we are looking for only here. So this is a strange idea, that somehow it is not in here where it gets its value from. However, if I look right here, and I do, as you can see, with the grep command, I can look for patterns in text files, and it says, yeah, the binary file matches, but binary file is no text file, so you can't look at it, look into it. And for the rest, it has only soft pwm.c and .h. .h has no values, .c does have, but you've just seen it's only this and nothing else. So how to change? I still don't know. I have to find out. Alright, I have gone back to my own code, and looking into it, I see the familiar line that with the PWM value between from 0 to 1024, then it reads the value that I give in on the command line, then pin mode, which actually sets this pin to PWM output. However, it is in a while loop, and it is kind of completely unnecessary to keep setting this one to PWM output. So what I am going to do is remove this line and set it here. This should work. Then why do I sleep? Is that necessary? I don't know. I'm going to try without sleep. So with these two changes, however slight, however minor, I am going to change it, and then I have to recompile. So let me find back the compilation line. It's been a while, as you can see. There we have it. Yes. Compile. I hope it does compile correctly. Yes, it does. So then I can actually run it again. Yes, here we have it. Let's go. Very good. Then let's say 1024, and then I'm going to measure the same thing as I did before. A pin on mass, on ground, and then at the PWM output, and it says absolutely 0, which is astonishing. I changed to 1, as you can see. Let me measure again. Zero. Somehow it apparently does not work, and I wonder why. Let me say 512, and once again it's totally 0, so there's no frequency now, which is kind of unexpected. So let me go back to my code. Why is this going on? I'm going too far now, or am I? No, I'm not going far enough yet. Here I am. Okay, let me change this back to sleep. compile, see if this matters. And run again. Let's say 1, because that is giving the lowest frequency right now. And it says nil, absolutely 0. Going to the max, which should give pretty high frequency. It doesn't. So this actually shows that my assumption somehow was wrong. And if none of this works, then I will change this again to this line. Compile again. I did not expect this to happen. That may be obvious. And let's test again. So, no, not this one. I want this. And then I set it to 1. And let's see what happens. If everything is alright, I should get at least some frequency out of it. And I do. 600. 610 Hertz. Now 1024 should give me quite a high frequency. Yes, around 8 to 9 kilohertz. Now what does 2048 do? If anything. The same. So actually apparently if I go beyond 1024, it just says I'm not going higher than that, which is quite surprising that the code does work the way it does, and raises a question how I can do things. So this is not the way to do it, and I apparently have to say the pin mode within the while, and somehow that doesn't make sense at all. So this is a void, a main anyway. These are all settings. A set direction to input, that is all fine. But why can I apparently not put pin mode outside the while? Really makes no sense at all. Because once you've set a pin, you've set it, and you don't have to set it again and again and again, while that is exactly what is happening now. So I think I'm going to be putting it this way again. Otherwise it doesn't make any sense to me. Have I made a mistake somewhere? Pin mode 1, because this is according to the library, which is alright. PWM output, I'm not getting any compiler error, so that is alright as well. Let's just try again. Maybe I made a slight mistake. Which is very well possible. So let's run it for 600 Hz. Let's check ground at measuring, and it says 0. Okay, so apparently I have to do it this way. Let me change it back. To its original location. Compile. And we are back where we were. And we have to see what we can do then. How to get the desired frequency. So, with the code back into the kind of original state. This is 600 again. I can go one step higher, value 2, and that goes immediately beyond the 1 kHz. So this is not the way to go, obviously. Software doesn't bring an obvious solution, although they say that it should be possible. The question is how, because I've shown you the code and apparently maybe I'm not looking in the right direction, which I doubt in this case. What I could do next time is to change my algorithm so that it goes in a loop through all the values, and then I only have to watch the frequency change, but I doubt that that is going to reveal something remarkable. In the meantime, although this should work, the conclusion for now is that it doesn't, and although this motor is a pulse width modulation driven motor, some things obviously do not work out. And when I put this the way this is, yeah, well, it just won't work. That may be obvious. So, new questions, new solutions, hopefully next time. And for now, thank you for watching. And if you like videos on this matter, or other videos on my other projects. Please support me by allowing advertisement between the segments, or visit my website, which is listed under this video, to find a way how to support me via PayPal, or rather the blog and the videos, me making them. And if you haven't subscribed to this channel yet, please subscribe, and in that way being informed by about new videos. And this is to be continued.